Okay, so if you're prepping for those senior software engineer technical interviews, it's not just about, like whipping up code.
Yeah.
It's about showing you get the why behind like the core programming ideas.
Right. Yeah, exactly. Like at the senior level, interviewers want to see that you really get why we use object-oriented programming, why we structure things the way we do. Not just that you can, code up a solution, but like, how does that understanding actually play into like when you're making big decisions about the architecture or the design,
Yeah, and I think that's a really cool area to dive into.
Yeah.
So today we're going to tackle how we work with objects, like at a fundamental level.
Right.
Right?
Yeah.
How do we use objects? What are they all about?
Yeah.
So let's think back for a second. Like way back, there was a time when programs were mostly built using functions, right? Like you call a function, it would do its thing and then spit back an answer. And one of the big things about that was being able to reuse code without needing to know all the little details about how it worked.
Exactly.
Yeah.
Functions were all about code reuse. Like you don't have to rewrite the same logic over and over again. You just call this function that somebody else wrote. It just works.
Right. So then why did we move away from that? Like, why do we need objects now?
Yeah, well, as software got more complex and we started building bigger systems, it became really hard to manage the state of our programs just using functions. It got messy, and that's where objects came in. And objects, they introduced this idea of state.
Okay, so for someone prepping for senior interviews, how should they think about state in this context? Like, what does that actually mean?
Okay, so imagine an object. It doesn't just do things, it also remembers things.
Yep.
Like it has its own little memory. And we call that state.
Okay,
And that state changes over time as the object does its work.
got it.
And the important part is that the state affects how the object behaves. Like a simple example. Think about the scanner in Java.
Yeah.
When you use in.next, the scanner keeps track of where it is in the input, like what it's already read. That's its state, that memory of what it's seen before. And that affects what you get the next time you ask for input.
Oh, so it's not just about the same operation giving you the same result every time. It actually has memory.
Exactly.
Yeah.
That history, that memory, that's what makes objects so powerful.
Got it. Okay, so you also mentioned this idea of encapsulation. I feel like that's a word that gets thrown around a lot.
Yeah.
What's the key thing for a senior engineer to understand about encapsulation?
So basically, encapsulation means you don't need to know exactly how an object works internally to use it effectively. Like think about when you're using a well-designed API.
Okay.
You just interact with the interface. You don't need to be an expert in all the details underneath.
Right.
And that's super valuable when you're working with libraries or frameworks.
Yeah.
You can trust that they'll work as advertised without needing to go digging through their guts.
Right. It's like that trust that things are going to work the way they're supposed to. Okay. So we have these objects. We know they have state. They're encapsulated. So how do we actually create them in the first place? Like, where do they come from?
So in Java, we use something called classes. And a class is basically a blueprint or a template for creating objects that all behave in a similar way.
Cool.
Like, let's say you want to work with calendar dates.
Okay. Yeah.
That gets pretty complex, right? You've got different month lengths, leap years, leap seconds. It's a lot to keep track of.
Yeah. Anyone who's ever tried to calculate date differences by hand knows it's a mess.
Exactly. And that's why we have classes for dates. Like experts in calendar calculations, they've created these classes that handle all the tricky stuff for us.
Right.
So when you need to work with a date, you just create an object from one of those classes. And then you can ask it questions like, what day of the week is this? Or what's the date after this one? You don't have to figure out all the rules yourself.
That's like they packaged up their knowledge into these reusable things.
Exactly.
Yeah.
And that makes our lives as developers so much easier.
Right. Okay. So now I'm thinking, even if we're not like sharing code across a huge team or anything, like even within our own little project or whatever.
Yeah.
Classes seem like a good idea.
Yeah.
Like, how do they actually help us as senior engineers?
Well, as your projects get bigger and more complex, using classes helps you structure your code in a way that makes sense.
Okay.
It lets you group together data and the operations that work on that data.
Okay.
And that makes your code base easier to understand, easier to debug, and easier to change over time. And that's super important for senior engineers.
Right. It's all about that maintainability.
Exactly.
Okay. So let's get a little more concrete here. Like you mentioned the Unix JICL program.
Yeah.
How would we do something similar in Java? Like, how would we print a calendar for a given month using all this object stuff?
Okay, so Java has this great class called LocalDate, and it represents a specific date.
Okay.
So let's say we want to represent the first day of a particular month. We could do something like this. LocalDate date equals LocalDate dot of year, comma month, comma 1 semicolon. And that would give us a local date object for that specific date.
Okay, cool. So now we have that starting date. How do we move through the month day by day?
So LocalDate has this handy method called +days.
Okay.
And you can pass in a number of days to add.
Okay.
So if we call date.plusdays, open parenthesis, close parenthesis, semicolon, that'll give us a new local date object for the next day.
Okay.
And the original date object stays the same.
So it's not changing the original. It's giving us a new one.
Exactly.
Okay, that's important. So now we have this local date. How do we actually get information out of it? Like, how do we know what day of the month it is or what month it is?
So LocalDate has a bunch of methods for getting information out of it. Like getMonthValue will tell you what month it is, and getDayOurMonth will tell you the day of the month.
Okay, and what about like the weekday? How would we figure that out?
Yeah, so there's a method called getDayOfWeek.
Yep.
And that returns an object of another class called dayOfWeek,
Okay.
which represents the day of the week.
Got it.
And then you can call getValue on that dayOfRent object to get a number from 1 to 7.
Oh, okay.
Where 1 is Monday and 7 is Sunday.
So it's like we get an object that represents the day, and then we ask that object for its number.
Exactly.
Okay. I also saw in the materials that you can chain these method calls together. What does that mean?
Yeah, so instead of writing like day of week, weekday equals date dot get day of week semicolon, and then on another line, int value equals weekday dot get value semicolon.
Okay.
You can just do it all in one line like this.
Right.
Int value equals date dot get day of week, open parenthesis, close parenthesis dot get value, open parenthesis, close parenthesis, semicolon.
Okay.
It just makes the code a little cleaner and easier to read.
Right. Like give me the day of the week for this date and then give me its number.
Exactly.
Okay, cool.
Yeah.
So now you mentioned that +days returns a new object. That gets into this whole thing about how methods interact with objects. Like what's the difference between an accessor method and a mutator method?
Yeah, so this is a super important distinction. A mutator method is a method that actually changes the object it's called on.
Okay.
Like it modifies the object's internal state.
Yeah.
An accessor method, on the other hand, doesn't change the original object. It might return some information about the object, or it might return a new object like +days does, but it leaves the original object alone.
Okay, so +days in LocalDate is an accessor because the original LocalDate object stays the same.
Exactly.
Okay, why is this distinction so important? Like, why do we care about accessors versus mutators?
So immutability, the idea that objects don't change once they're created, has become super important in modern software development, especially when you're dealing with concurrent systems where multiple threads might be accessing the same object at the same time.
Right, like in today's world where everything's multi-core, multi-threaded.
Exactly, yeah. And using accessors helps us create immutable objects,
Okay.
which makes our code safer and easier to reason about.
So it's all about like avoiding those weird bugs that happen when multiple things are trying to change the same thing at the same time.
Yeah. Exactly.
Okay, can you give me a quick example of a mutator's method just so I can see the contrast?
Yeah, so think about an array list.
Cool.
If you call the add method on an array list, that actually changes the list. It adds the new element to the list.
Oh, okay, so ArrayList.add is changing the object in place.
Exactly.
Versus LocalDate.plusdays, which gives us a brand new one.
Right.
Okay, that's really clear. So now let's go a little deeper here. Like in the materials, we talked about this thing called object references. What is a reference, and why is it important to understand, especially for senior level conversations?
Yeah, so this is a really fundamental concept in Java. When you create a variable that holds an object, that variable doesn't actually contain the object itself. It contains a reference to the object,
Okay.
which is basically like an address that tells you where the object is in memory.
Okay.
So it's like having a pointer that points to the actual object.
Okay, so when we write something like LocalDate myDate semicolon, we're not actually creating the LocalDate object right there.
Yeah. Right. We're just creating a space to hold a reference to a LocalDate object.
Okay.
The actual object gets created when you use the new keyword or a static factory method.
Got it. And this matters because...
It matters because of what happens when you assign one object variable to another.
Okay.
Like, let's say you have an array list called friends,
Okay.
and then you write array list string people equals friends semicolon.
Okay.
You haven't created a new array list. You've just created a new reference that points to the same array list.
Oh, so they're both pointing to the same thing in memory.
Exactly.
Okay, so if I change the list through one of those references, it'll change for both of them.
Exactly.
Yeah.
They're both looking at the same underlying list.
Got it. So this sharing of references, it can be efficient because you're not making copies of everything.
Right.
But it also means you have to be careful about side effects if you're working with mutable objects.
Right.
Okay, so that's where immutability comes back in. Like if you have multiple references to an immutable object, you don't have to worry about one reference messing things up for the others?
Exactly.
Okay, cool. So what about this special value null? What does that mean in the context of object references?
So null means that the reference doesn't point to anything. It's like saying this address doesn't exist.
Okay.
And it's often used to represent the absence of an object or a situation where an object hasn't been initialized yet.
Right. But I remember there's a danger with null. Like what can go wrong?
Yeah, the big problem with null is that if you try to call a method on a null reference, your program's going to crash.
Oh, okay. It's like trying to talk to something that's not there.
Exactly. And that's why it's generally good practice to avoid using null directly if you can.
Okay, so let's go back to those lines of code we were looking at before, like date equals local date dot of year, comma month, comma 1 semicolon, and then date equals date dot plus days, open parenthesis 1, close parenthesis semicolon. What happens to that first local date object after the second line? Like, is it just hanging out in memory somewhere?
So once the date variable is reassigned to the new local date object, the first local date object is no longer being referenced by anything.
Okay.
And in Java, we have this thing called garbage collection,
Okay.
which basically means that the Java runtime will automatically clean up objects that are no longer being used.
Oh, so it's like a cleanup crew that comes in and gets rid of the trash.
Exactly. Yeah. And that frees up memory for new objects.
Okay, that's super helpful.
Yeah.
And it saves us from having to do all that memory management ourselves.
Exactly.
Okay, so just to recap for everyone, we've covered a lot of ground here. We've gone from functions to objects with state. We've talked about encapsulation classes, accessors versus mutators, and object references. All of these are super important for anyone prepping for those senior level technical interviews.
Yeah, for sure. If you can show the interviewer that you understand these concepts deeply, it shows them that you're not just a coder, you're a software engineer.
Right, you're not just like hacking things together. You actually understand how the pieces fit together.
Exactly.
All right, so here's a final thought for all our listeners out there. As you're studying for those interviews, think about this. How does understanding these concepts like accessors, object references, immutability, how does that change the way you design software? Like when you're building a real system in the real world, how do these ideas come into play?
Yeah, that's a great question. It's something to think about.
All right, thanks for joining us for this deep dive.
You're welcome.
We'll see you next time.
See ya.